Hi everybody, this is Brad Vici of Northeast Kingdom Astronomy Foundation up in Vermont, and this is the second installment in astronomical image processing using free software called ImageJ. And in this video we're really just going to look at image handling basics and then start talking a little bit about histograms and how they can guide us through this process, how important they are in understanding what's going on with the image. For some basic information about how the program works, it's going to be easier to start with a non-astronomical picture, and then we'll bring in astronomy pictures a little later. So I've got the ImageJ program open, and I'm going to take an image here and drag and drop it onto this bar at the bottom. That's one of 3 or 4 different ways of opening an image. We don't use it that much with astronomy pictures, but it's a handy way. And so here's an image of a very cute dog. This is my doggy Homer a couple years ago. He's miserable because we're sitting outside on a day when it's sprinkling, and he has this lovely happy look on his face. But what I want to do is show you how I'm going to refer to this lower space in the ImageJ work. We're going to call this a dialog bar because I don't know what else to call it. So you notice that as I move my cursor around in this image, I'm going to put it on that white rock, what's displayed up there is an XY position that describes that location in the image. And then it says value equals. And if you can see really well, it says 204, 207, and 212. And then in parentheses, some number, some letter combination. I have no idea what the heck that is. But what the computer is storing for every single pixel in this image is an XY value and then a pixel value in red, green, and blue. And by convention, they're always in that order. This is an RGB image. This is the kind of image that you get from a cell phone. And it's an 8-bit image, because RGB images are 8-bit images by definition, which means that the value can only go from 0 to 255. There are 256 different possible values of intensity for each one of those 3 filters, for a red filter, a green filter, and a blue filter. So what you're getting, now I'll stop over here where it's Homer's forehead, and we're getting numbers of 33, 25, and 23. So very low numbers. Over here on this white marble rock, 253, 255, well, it's wiggling around a little bit. So very high values, almost pure white, which would be 255, 255, and 255. And everything else in between. We have some green leaves here, and you can see the red, green, and blue numbers. And so you can imagine that the computer could be called upon to you could say, well, give for any given XY position, or for all of the XY positions, it has stored these numbers. And you could say, well, just show me the red numbers. And then it would create an image for you that would be all the red values in all the XY positions on that entire image. And the same for the green and the same for the blue. And here's, in fact, how we can do that. If you don't believe it, let's take this image and we'll take it apart. And we'll go to the color menu, and we'll go down here and we'll say split channels. And we say yeah. And boom, fast as you can imagine, all of a sudden you get a stack of images. And I'm going to take each one and make them just a wee bit smaller so they'll all fit on the screen at the same time. So there's one, here's another one, and here's a third one. Let's see if we can get these to fit on my screen so you can see them. They overlap a little bit, but that's okay. This one up here, you may be able to read the fine print here, but this is the red image. And so this is what that whole image looks like through the red filter. And this is the green image. I've got it covered up, but I know it is the green image. I can put it on top. That's probably better. And so it says, there's the image name. It's a JPEG, and it says green, and we're at 12.5% of its actual size. And then over here is the blue image. And so you can compare them. There's some differences. They don't look that different. But this is the kind of thing that goes on when you take a picture with a cell phone or with a digital camera. What's being stored is this RGB information for every single pixel in the image. So in this case, I have no idea how many pixels are in this image because it's taken with a camera I no longer own. And so what you can do then is you can then, because you have these 3 separate images, you can take each one of these images and you can mess with it if you want to. And you could adjust its brightness and contrast, which is the one we use the most often. You can see that distribution of pixel values here. So on the x-axis is 0, meaning absolute black, and 255, meaning absolute white, and how many pixels at each one of those values. And by moving these, I'm adjusting this image here, it's the one I clicked on, and now by messing with these, I can change the way that image looks, brighten it, dim it, change the contrast and the brightness and all that stuff. And then I can recombine that image to create a composite that's a color image. And so now thinking about astronomy pictures, which look very different than this, although there are a couple of dogs up in the sky, but they don't look quite like Homer. Astronomy images have very different distribution of pixels. And this is where we come in to astronomical image processing. We start with these 3 images, an image taken through 3 or more different filters. So we have a red image, and a green image, and a blue image. We might have a luminance image, we might have a hydrogen alpha, an S2, an O3. We have other filters that we could be combining, and we might combine 6 or 7, but usually it's 3, a red, a green, and a blue. And then you can tell the computer which image goes in which channel. So let's put these back together again. We'll go down to the color menu. I went to image and then color, and now I can say merge channels. And now it asks me which one is going to be the red channel. And it automatically, it goes usually to the correct one, where the word red is there, the word green is there, the word blue is there. Now if I had other images, I could put them in different channels and say, well, I could take the hydrogen alpha and make it magenta or something else, but we're not going to do that, so we'll put this back together. And now we have a stack of 3 images, and I can tell that it's still 3 separate images in 2 ways. Up here, it says this is 1 out of 3, and there's how many pixels I've got. And because the text is in red, this is the red layer. And then down here, you can see that here's one layer here. I can click here, and now we're looking at the green layer, and I can tell that because up here the text is green, and it says this is image layer 2 out of 3, and I can go over here to the blue layer. I can still adjust these layers independently. And so let's do something like, I'm going to zoom way in on something. I'm going to zoom in until we start seeing individual pixels. I can also use the little hand to move the image around. And at this layer, we now have this image with 3 different layers. We can take those layers apart and move them. And sometimes with an astronomical image, you need to get the stars to line up exactly. If for any reason the alignment of the image isn't perfect, you've got a stack of 3 images here. You put one of them on the top. Well, I'm going to go over here, put the red image on the top, and then I can use Control A. On a Mac, that would be Command A, and then Control X. That says I'm going to apply this to the whole stack. That's what A means all. X means I'm going to cut. And now Control V, I'm going to paste it back down. But it's now an active layer. And I can use the left, right, up, and down buttons on my keyboard to move that image separate from the other layers. And I can use that to get the alignment just perfect between the stars. And I can do that for each different layer. I can put whichever one's on the top is the one that's going to move. And let's say I've got it just perfect. I like the way it is. And now one of the last things I do is go and go down to my color menu again, and I have to stack to RGB. Because right now it's a composite. It's a stack, but I need to create an RGB composite. And now it gives me a new color image. Happens to look exactly like the other one because I didn't make any permanent changes. But now this image is got the 3 layers put back together again, and I'm now getting 3 separate values up here in this dialog bar. I'm getting an XY value, and I'm getting a red, green, and blue pixel value. And so all those same things happen with astronomy pictures, except we don't start with a color original and take it apart. We start with those 3 monochrome images that we had. And let's look at the histogram for this image. So we'll go to Analyze and go down to Histogram. That's how you get a bigger histogram that's a little easier to see. I'm going to try to get it up on top. Park this image over here, and then put its histogram over here. Now that histogram has an enormous lump, continuous spread of gray values. Let's compare that now to an astronomy picture. So I'll say Open. And then we're going to go to an image take that one there. And here, okay, so here is the pixel distribution of a well-exposed color image. Now we're going to open up an astronomy image, which will look very, very different. And I'm going to go to File, Open, and I happen to have been looking at this file for the Rosette Nebula, so it goes there. I'm going to open up one of those frames. I'm going to move it over here so it's not on top of the doggy and the now notice that this image is just almost entirely black. And let's look at the histogram for this image. I'm going to go to Analyze and go down to Histogram. And it knows that I'm using this image because I click on this header first. And this is a common thing about ImageJ. You have to tell it which frame you're working on, which frame you're talking about. And then I'm going to go grab this and put it over here so I can keep it separate from the other image. And notice how it is a very different histogram. So this is absolute black on the left and absolute white on the right. Now it turns out this is a 16-bit image. As you can see, it's written up there. This color image is an RGB, which means it's an 8-bit image. So there's only 256 possible values, and 0 is counted. So the histogram goes from 0 to 255. We don't start counting at 1. We start counting at 0. And a 16-bit image has not 2 to the 8th possible values, but 2 to the 16th possible values. So now we have 65,536. Starting at 0, the peak is 65,535. That would be absolute white. And this shows you the distribution of pixels from absolute black to absolute white. And notice that almost all of our image is very nearly absolute black. In other words, there's almost nothing there. So let's get rid of this so that it's not in our way. And I want to show you that we can go here to Image, and we can brighten this up. I can show you that there really is, and we'll show you how to do this in a subsequent video. I'm going to move this over a bit. But we can leave, you can see there's a smaller version of the same histogram. Tiny bit of photographic information there. And the second one, the maximum, will move this little tiny indication. So this slanted line is moved up here. We want that one all the way over to the left. You want to have it just to the left side of whatever information is displayed. And then this one can be used to brighten your image. So if I go brighter, 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 still almost nothing there, just a few stars, almost nothing there. And if I want to make very fine movements, I can use this little arrowhead and move it more slowly, or I can hold it down and it'll zoom a little bit. But we got to go pretty far over here before we can see any detail in this image. Now there's something there. Look, there's actually a lot of really subtle information in here, and along you can begin to see a couple of flaws in the CCD camera too. But the job here in astronomical image processing is to tweeze out these very, very subtle details from almost nothing. You're almost creating, magic. And so the deal is, if we can get this histogram to push this information over into the gray values that we can see better, that would be helpful. And if that little histogram, instead of a little tiny spike, if we can get that to widen up so that we've got some latitude for adjustment, so it's not just black or just white, or just black and just blacker, so that'll give us some room to maneuver, and we can actually begin to adjust within those range of gray values to get the subtle detail of this image to come out and look much more beautiful. And that's what we're going to be doing in subsequent videos. We're going to start with the 3 monochrome images that represent the 3 different colors. I'm going to get rid of the doggy here and the doggy's histogram, and we're also going to get rid of the no, we don't want to save any changes. And so we're really going to be working primarily with images that look nearly black, like this. And the idea is, by stretching this image and going through a couple of processes to tweeze out that subtle detail and get this histogram to change the shape of that histogram. And the way we usually do that is by doing a logarithmic stretch, 1 or sometimes even 2. And what that does is it brightens the dimmer parts of the image without affecting the really high values. So it mostly affects the darker parts of your image. And it basically changes the difference between the brightest and the dimmest things in the image. And we can show you how to do that, and you end up being able to capture quite a lot more information. And we'll do that in the next video. We'll start off with an actual, astronomical image and a red, a green, and a blue channel, and then we'll go through the process of how you get a beautiful color image from 3 monochrome images that look like nothing, and how you can perform magic using free software called ImageJ. Thanks very much.